Welcome to Astronomy, Everaise Academy. I'm glad that you have made this far into this program and we are very proud to have you here. So without further ado, let's begin an introduction to our instructors. So first of all, my name is Trey Chin and I'm in my senior year in Malaysia, which is on the other side of the earth. If you're living in US, my time zone is exactly 12 hours ahead of you guys. And I have went to the International Astronomy Olympiad, which is actually is the Eastern Bloc Astronomy Olympiad. Usually the US kids go for the International Olympiad of Astronomy and Astrophysics, but we go for the International Astronomy Olympiad. But those two are roughly the same. It's just that there are geopolitical reasons behind two different Olympiads. And I will be introducing the next two instructors we have, which is Jeffrey and Faraz.
Hi everyone, I'm Jeffrey, and I'm one of your astronomy curriculum developers for this course. And I am a rising junior from Massachusetts in the United States. One interesting about myself is that I like to play card games, and my favorite part of astronomy is probably celestial mechanics. Hello everyone, and I'm one of the host and members of this camp. I'm a rising sophomore, and I like to play chess.
Right, next up we have Ebe.
Hi everybody. My name is Abhay. I live in India. I will be representing USA in the IOA this time. Um, I'm in grade 12. My favorite field is cosmology. Yeah.
Alright, so and the other two instructors, Yaman and Victoria. Yaman is from Nepal and Victoria is from Italy. So our team is actually sprawled throughout the globe with different time zones. So if you're from India or you're from US or you're from Moldova, anywhere on the world, we got you covered during the office hours, which we'll talk about later. Now, now it's time to get to know about you. So If you are in the Discord student server, just go to the Astronomy channel, hashtag general, and feel free to introduce yourself, what country you're from, what grade you're in, and one interesting about yourself. Don't be shy. Uh, we would really love to hear about you, what your interests are in astronomy, or what your favorite Messier object is. While we're waiting, we got Yaman here online with us, and he will talk about a little bit about himself. Hello. We have some lagging issues with Yaman here. In the meantime, please, we would really love to hear about you in Astronomy General channel, and our moderators are there to keep the discussion going.
Hello, I'm Yamanacharya. I'm from Nepal. I'm high school graduate. I just completed my high school in January 2021. So I'm an astronomy enthusiast and have been studying self-rolling astronomy since like early age. And I have represented Nepal in International Astronomy around 2019. That's just representing in astronomy.
All right. Thank you, Yaman. And Victoria is not with us today. She's at an astronomy award ceremony in Italy. So moving on, some details about the course. So our astronomy program starts today, July the 12th, and it's a 4-week program which will end on the 6th of August. It is a self-paced course, means that you can learn all the materials at your own pace. We won't force you into a faster pace, or if you need more time to enjoy the beauty of astronomy, sure, you can go ahead and maybe spend a day or two in the same chapter. Regardless, there will be office hours on Wednesdays and Sundays at Eastern Time 5 a.m. and 5 p.m. So no matter whether you're on the Eastern Hemisphere or the Western Hemisphere, we have got you guys covered. And we will explain more about the office hours later. About the units, we arrange our curriculum into 5 sections according to the IOAA syllabus, which is basic astrophysics, coordinates and times, the solar system and stars, stellar system and cosmology, and the fifth, instrumentation and practical observation. And the structure of this course is that it is mainly consists of handouts. Our team put a lot of efforts into producing these high quality handouts with beautiful diagrams, uh, well formatted equations, and yeah, I think you guys would love the handouts. And it's not the end of the story though, because we still have homework questions for you. In each handout, there will be three homework exercises for you to complete, and you can submit your answers to those homework problems on the Average Launch website. And then we'll talk about that in the next few slides. We will also have discussions on the Discord server and a problem of the week, which we will announce in the POTW channel. We also have some other activities like competitions and guest lectures later on in the course. Now, a bit about office hours. On every Wednesday and Sunday, you can go into the Astronomy Discord server to ask your questions into the question queue. And if you uh, there will be a slow mode implemented in the channel, so be sure to work your question carefully. Once you have asked a question, and if your question is if your question is voted to be a very popular or valid question, then our instructors will answer your question on voice chat regardless of whether your question is voted by a lot of votes. We will still answer all questions that you have. No question left behind, but with text. And also, if you have questions that are outside of the office hours, or if you cannot come to the Wednesdays and the Sundays office hours, you can still ask your questions into the question queue, and our instructors will answer them when they are free, but it will not be live. Next up, our course topics. So in basic astrophysics, we have our first handout, Introduction to Astronomy, and some basic physics modules. If you look at the handouts with the asterisks at the end. Those handouts are based on the Everaise physics department. So if you took physics last year or you are concurrently taking physics curriculum this year, you might find some overlap with these modules. But regardless of that, some of the homework exercises are revamped to give it a more astronomy style to it. And we also have coordinates and times where we will teach you the basics of the coordinates that we use in astronomy, like equatorial coordinates and alta azimuth coordinates and much, much more. And you need to get yourself mathematically prepared for a very rigorous trigonometric exercise for these four handouts. In the solar system and the stars, we will discuss about the ways to reduce observation when you are at Earth. So if you're at Earth and you look out into the solar system, how do you measure all those data? How do you process all those data? Like the phenomena of retrograde motion and all those things. We're at the end of the section, we will talk about the stars and how they evolve. And the fourth section, some people find it very interesting, is the cosmology section. We'll talk about large structures and uh, about deep time and very, very deep space. Lastly, we have the optics and practical observation, where we will teach you about the different telescopes and how do they work in principle, as well as some practical night sky observation, where you will learn about the constellations and Messier objects. And launch. Uh, if you have already if you have already logged into your account, you can see that you can have all these ongoing courses and announcements. We will post all the assignments on your dashboard, and you can answer this according to your own pace. I will talk more about how the attachment and the assignment works in the few slides later. Now, for the handouts, each handout comes with some important concepts and diagrams as well as example problems. So the difference between example problems and homework exercises is that the example problems have solutions written in the handout already. Now, our advice to you is that you must read actively into these handouts because we believe that you are already a very enthusiastic astronomy student. And make sure to take notes in your own notebooks because active learning is really, really important in self-paced learning. And uh, you can see we had a large screenshot here. This is where we will put our handouts out. So you will see our handout in a widget similar to this. And then for the homework, you have 2 attempts for each multiple choice problem, and you can submit a numerical answer to a short answer problem. We have only a few free response questions. So when you submit those free response questions, you don't need to submit those free response questions. You just need to maybe you uh, can write your answer on the notebook and then you can view the solution when you feel that you have the answer. And then for discussions, you can go to the astronomy channel and head to general or question queue to ask your questions or simply to have a chat. You can even have chat with the other students as well. But make sure to check the rules and just be kind. Don't spam, don't give any uh, unwanted advertisement. If you are unsure about what is okay or not, you can ask any of the moderators in the roles. And please, guys, if you want to give spoilers, mark those spoilers, alright? We also have problems of the week where our instructors will give uh, a very, very challenging problem on the POTW channel. So these problems are usually from international Olympiads, either the IOAA or IFO. But contrary to the homework problems, we actually encourage you to work with each other to tackle the homework problem. So uh, you don't need to just go your solo on this. You can utilize the power of our Everest community. But if you have an answer to it, please mark it with spoilers. We also have some other activities like guest speaker event. Uh, at the end of the course, we'll invite amateur astronomer to give a talk on astronomy as well. There's also some cool guest lectures by the physics department as well. I believe there's a guest lecture by MIT undergraduate, and there's also a guest lecture by a few professors in the United States. So you can check them out in the Everaise website for their schedule. And for those that have already been posted, you can head out to the YouTube channel. We also have some games and competitions. For the competition, we will have end of the program mini USAAO mock exam. So the format will be similar to the USAAO, and we might have some prizes. So read actively and make sure to ask any questions that you have. So if you have any questions, you can just ask in the channel or in the YouTube live chat. So here we have a question. Is it required to solve all the questions in a handout? Um, I will see that it is not much of a requirement, but an encouragement. Because from solving all these questions, you can gain a lot from it. Reading is never enough. And actually, we have taken student workload into consideration from last year's feedback. So each handout has only three problems only. So I believe that three problems per handout is a fairly reasonable workload for you to at the same time master the content, but not to tire yourself entirely. We have another question coming in. How comfortable should I be with my Olympiad rounds after this course? I think that after this course, you will have uh, at a very, very good advantage compared to other students who didn't have any access to this free course because much of the course materials we cover now is very, very advanced. It is accessible to others using textbooks and all, but this free course material is uh, it's very hard to digest for a layman because speaking from experience, when I prepared for my country's uh, national Olympiad and National Astronomy Olympiad selection test, it is very hard to learn from the Roy and Clark Astronomy Principle and Practice textbook uh, entirely. Uh, Also, the Finnish we had a textbook from the Finnish authors called Fundamental Astronomy, and it is very, very difficult to grasp all the contents straight from a university textbook. So I think after the course astronomy course, you would have a very, very good lead over other competitors in your country. Will anything be taught in office hours? Actually, it depends because if the question you ask is very inspiring or it requires a new concept that is not taught in the handout, maybe our instructors will give a lesson on it, but it's up to each instructor. Regardless, our instructors are very enthusiastic, so uh, yeah, just get your notebook ready because you will maybe learn something new during the office hours. What should be the time commitment for this course? So this is the self-paced course, but if you look at the time frame, we have around 29 handouts. We have around 30 handouts for 4 weeks. 20 handouts for 4 weeks. So I think you can spend like 2 days for one handout, and you can even have another program concurrently run at the same time because this is a self-paced course. Can a complete beginner take this course? Yes, a complete beginner can definitely take this course. You don't need any knowledge on astronomy beforehand to tackle this course full on because we will provide all the basic prerequisites that you need in our basic astrophysics section. I would recommend you to have uh, a- some basic knowledge in calculus because we need some calculus to help deriving the theorems, but it is not required because derivations are not required in the international Olympiads as well. But with calculus, you can have a deeper understanding into the theorems, how it is made, especially